All right, in this lesson, we are going to talk about functions and function notation. And so the formal definition of a function is a relation of a set of inputs from the domain to a set of outputs. It's kind of like a mapping or a machine where it takes inputs, which are going to be your x, and gives you an output, which is going to be your y. And so in order to be a function, each input, x, can only give you one result, y. And so I like to think of a vending machine. If you put in an input of money, you should only get one thing out of the machine for each time you put in a certain input. Okay, and so x, your input, is the independent variable. And then y is the dependent variable. It depends on whatever x is. And so we switch our notation. Instead of using x comma y, we replace the y with f of x. So that way we can see which input gave us that output. So it's just notation. And so whatever is inside the parentheses is always going to be your x value. Whatever's outside the parentheses is going to give you the output, the y. Okay, and so looking at an example, we have a function that takes x as its input variable, and the rule says multiply by 2 and then add 1, and that's going to give us our output. And so we're going to find the outputs for each of these inputs. So f of 5 means x is 5. And so for our rule, we replace the x variable with 5. And then 2 times 5 is 10, plus the 1 gives us 11 as our output. So we would answer that f of 5 would give us an output of 11. If we put 5 into this machine, we're going to get 11 out of the machine. So each time you see something in parentheses, that's what you're replacing x with. So for this next example, we're going to have 2x plus 1, same rule because we're still using f. And then negative 3 is going to be our input this time. 2 times negative 3 is negative 6. Add 1, we get negative 5. So f of negative 3 gives us negative 5. Here we're using 0 into the f function. 2 times 0 is 0. Add 1, and we get 1 as our input. And so something that's important to note is that we use letters to name the function. Most of the time we use F, we could use G, we could use H. We're seeing different letters to represent functions. And so letters don't only represent variables, they also represent functions, and so you really have to know your context. Okay, in these next examples, we have 3 different functions. One of the functions is F. It says multiply your input by negative 3, then add 5. Our other function is G of x. It takes your input and divides it by 4 and then subtracts 2. And then we have H, which just adds 1 to the input. Okay, and so looking at these next 3 examples, they look different than the first 3. In the first 3, the number we were given is inside the parentheses. Inside the parentheses, inside the parentheses. Inside means it's your input. We're going to put it inside the function, just like inside the machine, to get the output. In these next examples, notice the parentheses are here. We don't know what x is. We now know the output. The output in each case, because it's not what's inside the machine, it's what's outside the machine. And so here we're trying to figure out which x value gave us an output of 23. And so if we're thinking of the vending machine example, if we put 5 into the machine, we get 11 out of the machine. 5 is like your money, and 11 is like the soda or whatever the machine you're using. Okay, and so here we're given the soda, the output, and we're trying to figure out what the input was. Okay, and so because they are using f, the f machine, the f function, we have to use f's rule, which says negative 3x plus 5, and we set it equal to that 23, and then just solve for the x. So our first step is to isolate the variable by subtracting 5. Always get rid of the number that's not attached to your variable first. And so 23 minus 5 is 18. And then lastly, we can get rid of this multiplication by negative 3 by dividing, just using our inverse operations. So we end up getting x equals negative 6. So if I put negative 6 into this function, I would get positive 18 plus 5, which would give me that 23 back. And so we could tell them x equals negative 3 as our input. In this next example, they're using g. And so g says x divided by 4 minus 2. And we're told it equals negative 10. Don't put negative 10 in for x. That's not your x. We're trying to find x. So same situation, we need to isolate the variable. So add 2 to both sides. And then to get rid of this 4, because we have division by 4, the inverse operation would be to multiply both sides by 4. And so x equals negative 32. Then again, you can plug that in for x into this g function, and you would see that the output would be negative 10. Lastly, we have h of x equals 0. And so h of x is the same thing as x plus 1, and it's set equal to 0. And so subtract 1 from both sides, we know x equals negative 1. Right? And so for these practice problems, we're given 4 different functions. And in the case of the first 5, you are given x values. X is 7. X is negative 6. Or in 3, we're given a y value. We don't know x. So you're trying to find the x. Okay, and so looking at number 1, it says, I'm going to color code these. And so let me get rid of all that. Okay, so I am going to make f of x red, g of x blue, h of x green, and we'll make j of x gray. Okay, so our first problem says h of 7. So we need to look at the h function, which is here. And so h of 7, we have to do x plus 3 over 5. And in this case, we're replacing x with 7. I like to put parentheses there. They're not really needed, but it's just a good habit. So 7 plus 3 is 10, divided by 5 is 2. So our answer for number 1 is 2. Next, we're using g of x, and we're using negative 6 for our x value. So g of x is here, which says negative 1/2 x minus 4, and we're putting in negative 6 for the x value. Negative 1/2 times negative 6 is positive 3. 2 negatives multiplied together make positive. And then we have to subtract 4, which gives us negative 1. And so our answer for 2 is negative 1. Okay, 3, they're flipping it on us. They're using the f function, which is 2x plus 1. But this time they're giving us the output. So we know 2x plus 1, whatever x is going to give us that 15. And so we have to say what x is. So first step, subtract 1. And then divide by 2, we get x equals 7. In these cases, we were giving the y value. Okay, here we're using j, which doesn't even have a variable in the rule, it's just 4. It says j of x equals 4. So no matter what you plug in for x, and in this case we're plugging in 0, it's only going to give you 4. It doesn't depend on x. This is called a constant function. And so no matter what, I could plug in 100, I could plug in 1,000,000. I'm still going to get 4 as the output because there's no x there. Right, back to f. F of -3, that's going to be our x value. Our rule is 2x plus 1. And we're putting in -3 for the x, which gives us -6 plus 1, which gives us -5. And then h of x equals 0. Our rule for h is x plus 3 over 5, and that equals 0. So our first step is we need to get rid of this 5. The x plus 3 is trapped above this division bar, and so we need to get rid of this 5 first by multiplying both sides by 5. So the 5's cancel, leaving me x plus 3. 0 times 5 is just 0. And then lastly, we subtract 3 from both sides, and we get the answer of -3. So it's a little bit easier when they give you an x value because you're just plugging it into the function and then number crunching. It's a little bit harder when they give you the output because you actually have to solve for x. You have to isolate the variable using your inverse operations. Okay, this next section, we are looking at function notation on a graph. So our y-axis is the vertical axis, our x-axis is the horizontal axis. And so the biggest thing is just noticing whether you're given the x or the y. So looking at A, the -4 is inside the parentheses, so we know that our x value is -4, and we're trying to find the output, or the y value. And so we're going to go to our x-axis and go to where x is -4, and then go to the function and see what the y value is. And so the y value at -4 is +2. And so we have the point -4, 2 on our graph. And so if the question asks, what is f of -4? Your answer is 2, just 2. That would be the output, the y value. Okay, this next one, they're saying f of 0. And so we're going to go to where x is 0. And we're trying to find the output, or the y value. And so the output value, since this point is 0, 0, our output value is 0. So f of 0 is just 0. Here we're given f of 2, so 2 is our x value, and we're trying to find the output, or the y. So we go to where x is 2, and then the y value here would be -2. And so at -2 is the output that goes with x equals 2. For -5, that's our x. It's inside the parentheses. So we're going to -5, and we see that we have the point -5, 0. The y value is 0, and so our output is 0. This next example, they are not giving us the x. The x is inside the parentheses, unknown. We're given the output value. And so we're trying to find the input that gives us an output value of -2. And so because this is a y value, we're going to our y-axis at -2. And we see that we have the point -2, or +2, -2. And so our answer for this is x equals 2, would result in an output of -2. Same thing here. They're telling us our output is y, and so if we're thinking of the ordered pair, we're trying to figure out the x that goes with an output of y. And so y equals 0 is the x-axis. Here's y equals 1, here's y equals 2, here's -1, -2. So here's the y equals 0 line, and we actually have multiple points here. We have this point here, negative 5, 0, and we have the point 0, 0. So we have negative 5, 0, and we have 0, 0. So we have two different answers that we can give them for an output of 0. You would say negative 5 or 0 for your answer.